Please put down. Alcohols are hydrocarbons. Alcohols are hydrocarbons, also referred to as alkanols. Which contains one or more hydroxyl groups, in brackets OH. One or more hydroxyl groups, in bracket OH, connected to one or more hydroxyl groups, in bracket OH, connected to a saturated carbon atom. Alright? So these alkanols contain one or more, which means that they can contain one, they can contain two, they can contain three, they can contain four. So any organic compound, any hydrocarbon that contains one or more hydroxyl group connected to a saturated carbon atom, okay, is referred to as what? An alcohol or an alkanol. Are we together? We'll stop. The general molecular formula for alkanols. Is given as CnH2n plus 1, then OH. The general molecular formula for alcohols is given as CnH2n plus 1, OH. Okay? Or in bracket, you can say CH, for instance now, CH3OH is known as methanol. Okay? CH3OH is known as methanol. So it is more like an alkyl group linked with a hydroxyl group. An alkyl group like methyl, ethyl, propyl, butyl, like that. Alright? So an alkyl group leads to OH, or we can say connected to a saturated carbon atom, that is OH, connected to a saturated carbon atom. Alright? So general molecular formula is CnH2n plus 1 OH. Are we together? Alright. Now the first 10 members of the alkanol series. The first 10 members of the alkanol series are number 1, methanol. Methanol is CH3OH. Number 2, we have ethanol. Ethanol is C2H5OH. Number 3 is propanol. Propanol is C3H7OH. Number 4 is butanol. Butanol is C4H9OH. Then we have pentanol. Pentanol is C5H11OH. Alright? Whenever you get the word pent, please note that we're talking about 5 carbons. Then we also have hexanol. Hexanol is C6H30OH. Then we have heptanol. Heptanol is C7H15OH. And the list continues. Alright? We have octanol, nonanol, and decanol. Alright? So we have octanol, which is C8H17OH. Then we have nonanol, which is C9H19OH. Then lastly, decanol. we have C10H21OH. So these are the first 10 members of the alkanol series, or we can say these are the first 10 alcohols. These are the first 10 alcohols. We have methanol, we have ethanol, we have propanol, we have butanol, we have pentanol, we have hexanol, we have heptanol, we have octanol, we have nonanol, and we have decanol. So basically, it is increasing with an increase in carbon atom. So normally, you would agree with me that, like I said previously, hydrocarbons like this tend to increase with one carbon and two hydrogens. One carbon and what? Two hydrogens. That's why we have CH3CH5 in that order. Alright? In that order. Okay? Now please take down. Take down. Members of this series as seen above. Members of this series as seen above have the suffix OL, all. Have the suffix OL. So members of this series are seen above. And if you notice, methanol, ethanol, all. If it is an alkane, methanol will be what? If it's an alkene, ethanol will be what? Ethene. If it's an alkyne, ethanol will be what? Ethane. Alright? So most of these members belonging to a particular family are usually named with the suffix of the what family that they belong to. The suffix of the family they belong to. Are we together? So now let us quickly look at nomenclature of alcohols. Nomenclature of alcohols. Nomenclature of how can we name alcohol structures? That's what we want to look at now. When we are presented with structural formulas, skeletal formulas, as the case may be, regarding to alcohols, how can we name them? Now, okay, please take down. The nomenclature of alcohols follows the general rule of naming organic compounds. The nomenclature of alcohols follows the general rule of naming organic compounds. Okay? Number one, I will give you the general rule, I will be reiterating the general rule again. Number one, count the longest continuous carbon chain in the structure. That's the first rule. Count the longest continuous carbon chain in the structure. Number two, number from the end. The first one is to count the longest continuous carbon chain in the structure. Number two, number from the end of the chain. Number from the end of the chain, which gives the hydroxyl group. Which gives the hydroxyl group a priority as the smallest possible number. Which gives the hydroxyl group in bracket OH a priority as the smallest possible number. So basically, when you are numbering your chain, remember that when you get the longest continuous carbon chain, that serves as the parent name of the structure. So when you are numbering your chain, you try as much as possible to number from that side, from the end, that will give the carbon that contains this hydroxyl group the smallest possible. Basically, when we have gotten the longest continuous carbon chain, we said that the parent name. Number two, like I said, we will number from the ends that will give the hydroxyl group OH, the carbon containing OH, the smallest possible number. Is that okay? Alright, have you written that? Now, full stop. This is done before considering the substituents. This is done before considering the substituents. This is done before considering the substituents. Okay, which is based, this is done before considering the substituents, which is based on having the same number for the carbon containing the hydroxyl group on both ends, which is based on having the same number for the carbon containing the hydroxyl group on both ends. You understand what I mean? So before you consider the substituents, if you have, I said this is based on having the same number, okay, for the carbon containing the hydroxyl group on both ends. What I'm saying in essence is that if you have a chain, and you have counted from this end, and the carbon containing the hydroxyl group is on carbon 3, you counted from this other end, the carbon containing the hydroxyl group is also on carbon 3. At that point, that is the only time you should consider the substituent. Is that okay? Do you understand? Alright, so quickly, we'll go into naming some alcohol structures. But before that, okay, let's complete the rules. What number are we now? We have finished number 2, right? Now number 3. Number 3. After you must have done that number 3, okay? Now attach numbers to each substituent. Attach numbers to each substituent in the chain. Attach numbers to each substituent in the chain based on their various positions. Based on their various positions. So whichever position the substituent is, if it is attached to carbon 2, it means that it will be 2, for example, it will be methyl. It will be 2 methyl. If attached to carbon 4, it will be 4 methyl. If it is methyl, attached to carbon 5 methyl, like that. Alright, and that's form. Okay? Then rule number what now? Rule number 4. Rule number 4, okay? Alcohols are named in alphabetical order like all organic compounds. Alcohols are named in alphabetical order like all organic compounds. Have you written that? Like all organic compounds, comma. In lower cases, and for multiple substituents, we use prefixes such as di in bracket 2, tri in bracket 3, and what? Tetra in bracket what? 4. So multiple substituents, that is something that appears more than once. If a substituent appears more than once, if it is twice, then if that's not going to be methyl, it's a dimethyl. If it is thrice, that's not going to be methyl, it's a triethyl. If it appears 4 times, tetramethyl, and all of that. Just the same way we name other organic compounds. Okay? Just the same way we name other organic compounds. Alright, is that taking? Now lastly, please take that. Okay? Now alkanol structures, okay, containing 2 or 3 hydroxyl groups. Alkanol structures containing 2 or 3 hydroxyl groups are referred to as diols and triols, respectively. So any alkanol structure, any alcohol that has 2 hydroxyl groups, we call it diol. 3 hydroxyl groups, we call it what? So as a matter of fact, just like we have alkenes, that when you have two double bonds, it's called what? It's called what? Diene. Three double bonds? Dienes. Alright? In this case, alcohols are called diols when they have two hydroxyl and thiols when they have three hydroxyl groups. Okay? So now let's look at an example. Okay? Please take that one. Name the following alcohol structures below. Name the following alcohol structures below. So we are applying our principles to naming the following structures. Now look at it, guys. If we have number one, we have a structure like this. I always like mixing up the structures, skeletal and structural. So we'll get used to both of them. So we're looking at three different structures that will help us to, or I'll just write four different structures that will help us to understand the concept of this better. CH2, CH3, and here we have CH2, CH3 as well. Here also we have CH2, CH3. Please let's try and differentiate them. This OH is attached to this structure. Hope is visible. This OH is attached to this structure. This one, like basically this structure, this number 3 is like this. Alright? This number 2, this number 1. Okay? Then the fourth one, I'll make it to be in a skeletal form. Alright? Okay. So let's take down these four structures. We'll name each of them one after the other. Start with number 1. Okay. Now let's start number 1. Let's start the first one. Alright? I'll need your maximum attention here. Okay? First of all, like we have in the general nomenclature, we have to count the longest continuous carbon chain. We have to count what? The longest continuous carbon chain. Beautiful. And now when I say longest, I'm talking about the chain that has the most or the maximum number of carbon atoms. without returning. Counting like this, for instance, the straight chain, you count 1, 2, 3, 4, 5, 6, 7. I've explained the concept of skeletal structure. That each point we have here is a carbon. Am I correct? Yes. Each point we have here is a carbon atom. So looking at that, when we count from here, we have 1, 2, 3, 4, 5, 6, 7 in the straight chain, right? We can also count from this top. If we count from this top, we have 1, 2, 3, 4, 5, 6. But now listen, it's very important to note that your hydroxyl group must fall in that parent chain. Now look at this. If we decide to count from here, we have 1, 2, 3, 4, 5, 6, 7, what? 8. And that is the longest, right? Because like this 1, 2, 3, 4, 5, 6, 7. This one is 7. Okay? So but this one, every point here is a carbon. 1, 2, 3, 4, 5, 6, 7, and what? 8. So anything that is not part of the parent chain is called a what? A substituent. A substituent. It's called a substituent. I've said it countless times. So basically, it means that this is the substituent, right? Because it's not part of the parent chain. This is also a substituent. It's not part of the parent chain, right? So the parent chain is from here to here, is it not? 1, 2, 3, 4, 5, 6, 7, 8. When we have 8 carbons, what kind of alcohol is this? Octanol, right? And now, like we have for alkenes, the name of this structure must carry the position of the alcohol. If the alcohol is at carbon 2, we will say octan 2-ol. Okay? Octan what? 2-ol. Are we together? This is at carbon 5, and it is 6 carbons in the longest continuous carbon chain. We will say hexan 2-ol. Are we together? So the position of the hydroxyl group must be taken cognizance of. So now look at this guy. This is a substituent, right? And this substituent has 2 carbons, right? 2 points. This is not part of the substituent though. Everything here is carbon, 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 carbon what? Carbon. Okay? Here it's carbons. The different points are carbon points. One thing we need to understand is that even in these substituents, these are also carbons. These points here are also carbons. So if you look at the substituent, and this substituent has 2 carbons, and when you have 2 carbons in this ethyl, is it not? Yes. It is called ethyl. 1 carbon is called ethyl. 3 carbons propyl. Alright? So this one has 2 carbons. 2 carbons. Is there any other substituent here? No. So the idea is to come from the end that will give the hydroxy group the smallest number. Men and brethren, if you come from here, hydroxy group will be at 1, 2, 3, 4, 5, 6, 7. But if you come from here, the hydroxy group will be at carbon what? Carbon 2, 1, 2. So it means that this is the what? Perfect number. So we say 1, 2, 3, 4, 5, 6, 7, 8. That's the perfect number. We come from the side that we give this hydroxy group the smallest number. We are not numbering the entire structure. We are only numbering the chain. We are only numbering the what? The chain. Very important to note. Only the chain. That's what we are numbering. So after numbering this chain, we have realized that our substituents are at carbon 4 and 5, right? Yes. And our substituents are the same. These substituents are the same in type. So it means that the name of this structure will be 4 over 5. When you're writing 2 numbers, use comma to separate them. Then I think diethyl octan 2 what? Or diethyl 2-octanol. Which do you prefer, first or second? Some people say yes, some people say first, some people say second. Alright, but both of them are correct. Okay? Just like for our kings, okay, when we have 2-octene or oct2e, alright, octan 2-octanol, both of them are correct. Okay, so where these two, you might be wondering, where is it coming from? The 2 is coming from the position of the hydroxyl group. The 2 is coming from the position of the hydroxyl group. 4, 5, this ethyl is at carbon 4, this ethyl is at carbon 5. Are we together? Now let's move straight to the second structure. Now for the second structure, we have an alcohol group here. But you know, as our culture is, we have to first determine the longest continuous carbon chain, right? Now, if we have determined the longest continuous carbon chain, the straight chain is 1, 2, 3, 4, 5, 6. The straight chain has 6 carbons, right? But now, if we move like this and we go up, we'll have 1, 2, 3, 4, 5, 6, 7. 7 is what? Heptanol, right? Good. So now, in this particular structure, we have just 2 substituents, this and this. We have chloro and we have methyl. So like this now is the parent chain. Like this is the parent chain. This OH, is it a substituent or a group? This OH is a substituent or a group? It's a group. That's what makes it an alcohol, the presence of OH here. But when we look at carboxylic acid, I will also show you that OH can be a substituent. OH can also be a what? Alright, when we look at carboxylic acid. But now look at this, guys. We do not have to do it now, right? We don't have to do it, we're doing it. We come from the end that we give the group, the smallest possible number, right? We start from this end to be at 1, 2, 3, right? OH to be at carbon 3. But you start from here to be 1, 2, 3, 4, 5. So which is the smallest? 3. So you need our number from here. You say 1, 2, 3, 4, 5, 6, and what? 7. Now let us go and name it. So name of structure 2. Name of structure 2. We have 2 substituents at carbon 3 and 5 respectively, right? Now we have to name it in alphabetical order. So chloro will come first before methyl. Yes. So we have 3 chloro, 5 what? Methyl, hyphen again. No. Do we have any other substitute? No. We don't have any other substitute now, right? So heptan what? 3 what? Or. Right? Or we can say 3 chloro, 5 watts, methyl, 3 watts, heptanol. Okay? Is there an issue? Okay, now this hyphen I put here because I'm coming down. They're not supposed to be hyphen here. I'm coming down, so I just put hyphen because I'm coming down. Normally they're supposed to be hyphen. You don't separate letters with anything. Just like here, I just wrote the type of 2 or without putting hyphen. The only place you put hyphen is when you're separating numbers from letters. If you're separating numbers from themselves, you put comma. If you look at it very well, do you see any capital letter? Do you see any capital letter? There's no uppercase, which implies that it must all be written in small letters. As it is. Why is it not in the parent chain? It is. It is in the parent chain. It's attached to the carbon in the parent chain. It's attached to the carbon in the parent chain. It includes. It must not. The carbon cannot bond to OH. You cannot have something like C, OH, and C again. Carbon does not bond to nitrogen and oxygen in this form. to show that it is bonding. Do you understand? Okay, beautiful. Now let us look at the third structure. Let's look at the third structure, guys. Okay, so we have OH here, right? Like any other thing. Is there anything I need here? No. Alright, so this is exactly how it is, right? Good. Now, let us look at the third structure. Okay? For the third structure, we count the longest continuous carbon chain as we've always been doing. If we count, we have 1, 2, 3, 4, 5, 6. Even the straight chain is long. Even like this, you can still go. We can count anyway, but anyhow we count it, we still arrive at the same answer. Okay? So let us just take the straight chain. Let's take the straight chain. Okay? So are we supposed to settle OH as a substituent? No. We settle CH3. We settle CH2, CH3. We settle CH2, CH3. Alright? OH is part of the series. It's a group that forms the series. Okay? It's a group that forms the series. So now, what we have to do now is to number the chain in such a way that these two hydroxy groups we have the smallest number. Let us start from here. If we start from here, we will have 1, 2, 3. Hydroxy group will be about 1 and what? Are you seeing it? When we start from here, it will be 1, 2, 3, 4, 5, 6. 4 and what? 6, which is long. But 1 and 3 is better, right? 1 and 3 is better, right? So if that will count from here 1, 2, 3, 4, 5, and what? 6. So at this point, we have realized that this is the best numbering pattern for this structure. We have 3 substituents. We have 2 ethyls and 1 ethyl. And you know, as our culture is to write in alphabetical order, right? So ethyl is one first, is it not? So we'll say for number 3 structure, we'll say 4. What of them are carbon 4 now, is it not? So we'll say 4, 4, di-what, ethyl, 3 methyl, right? Okay. So 3 methyl. Okay. How many carbons are in the long chain? 6. So we'll say hexane, hyphen. Now listen. The hydrogen groups are carbon 1 and 3, right? So we say hexane 1, 3, diol. Hexane 1, 3 because there are 2 hydrogen groups at carbon 1 and 3. And because there are 2, you must use di. You will not just say all like we have been doing here. We have been writing just all because it is just 1 hydrogen group. You understand? So here, we are saying diol because there are 2 hydroxy groups. If there are 3 hydroxy groups, it will be called what? Triol. Triol, right? Beautiful. Okay. So now let us look at, I believe this structure is clear, right? We are clear on this structure, right? Okay, you have a question. Please ask me. Okay, we cannot say 4 di because if you are using a prefix di, you must indicate where the 2 substituents that are the same are attached to. You must indicate their positions. Even if there are 20 and there's any prefix for 20, you would write all the positions for the 20 substituents. Is it clear? It's a must. You cannot just say 4 di. 4 di. Even if they were on different carbons, they are 4 5 di. Is that clear? Beautiful. Now let us go straight to structure 4. Alright, the last one of this structure. Okay? So let us name this structure together. Now the longest continuous carbon chain is our priority here. First, it's our first priority. Okay? So now let us do it. Remember, I told you that every point here is a carbon, right? Every point. The structure is not confusing, is it? It's not. If we count the straight chain, okay, 1, 2, 3. Look at this one. Look at this. This is a carbon. carbon, carbon. There's another carbon here, carbon here, carbon, carbon, here, carbon, 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 carbon. Right? Is there carbon here for OH? This is the bond that is bonding to OH. This is the bond bonding to OH. This is the bond bonding to OH. This is the bond bonding to bromo. It is here that we have the carbon. There is no carbon here. This is the bromine bond. Is that clear? So let us get the longest chain. So I think the longest chain should be from here to here. How am I correct? We have to be very meticulous. Okay, now let us start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. But if you start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then now from here down to what? Here. So we have to be very careful now. Now that we have been able to get the parent chain, so it means that this is a substituent. Am I correct? Yes. Am I correct? Is this also a substituent? Yes. Am I correct? Yes. Is this also a substituent? Yes. Is this a substituent? Yes. Any other substituent? No. Any other substituent? No. If you're not meticulous, if you don't take your time to look at it very well, you may make mistakes. Okay, so we have 1, 2, 3, 4. We have 4 substituents. 10 is decanol, right? So we have 10 carbons in the long chain. Now we have to count the long chain to give us the smallest possible number for the groups. Okay, so let's do that quickly. So now, if we do that, if we start from here, we have 1, 2. I see it. This group is connected to carbon 2 here. From your numbering from here. We will number from here, we also check from here. Is that okay? Now let us check from here. 1, 2. Okay? 2. So we have 2, 3, 4, 5. 5, right? 2, 5, 6, 7. Right? So 2, 5, and 7. Let me do it again. 1, 2, 3, 4, 5. Carbon 5, 6, 7. Carbon 7. Then if we count from here, it will be 1, 2, 3, 4. 4, 5, right? 6, 7, 8, 9. This one is off already. This one no full, right? No full at all. So it means that we take 2, 5, and 7. So if you have to number from here, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you look at this thing, for instance, you just come to the class and you look at this thing for the first time, will you not be confused? You will. But once you know it, you will know why this is like this. You don't see C3, C2, Nokia C1. How many of you remember Nokia C1? People even know Nokia C1. This is Gen Z. This is Gen Z generation. It's what? It's what? Back then we were using C1, C2, okay? Someone says C1. Okay, let's proceed, guys. Okay, now, we are taking this pattern of nomenclature. Okay? Now, let us arrange the nomenclature based on the substituents here. You know, we have to do it in alphabetical order, right? So, which one comes first? Bromo is zero. Bromo is like about what? So, 6 words. Bromo, which are substituents? We have 2 ethyls, right? Yes. And we also have propyl. Is it not? Propyl because it has 3 carbons. So, and for ethyl, these 2 ethyls are carbon 4. Okay? These 2 ethyls, look